Hey guys, welcome to the video for solving systems by substitution. We're in Unit 5. Our essential question is, how is the substitution method used to solve a system of equations? So this is just day 1 going over substitution. We will have day 2 where we go into it more in depth, but day 1 is an introduction and just getting used to what substitution is. I'm not feeling so great, so my voice does sound a little raspy, so I apologize about that. But I am going to be switching from here to Desmos quite a bit, so I will have that open just so that I can show you what's kind of going on while we do these problems, okay? All right, so starting off, we have some vocab. Substitute. What does it mean to substitute something? Well, you think of maybe of a substitute teacher, right? What is a substitute teacher's job? Well, their job is to fill in for the regular teacher for the day, right? So substitute is maybe to fill in or replace. But in math, when we say substitute, we say plug in. Okay, so when I'm asking you to substitute a number in, you would plug in that number. So I'm going to give you an example here, okay? So this is going to be a super easy example because I just need you to understand what we're kind of doing today. So if I have 7x plus 3, right? Let's just say I have this expression, 7x plus 3. And then I tell you x equals 5. Well, what could you do with this information? What could you do with this number 5? Well, you know that x equals 5, right? So you could substitute it in. You could plug it in for the x over here. You have 7x plus 3. You know that x equals 5, so plug it in. And when you plug in, you always use parentheses. So I plug in, so I take out the x and I put in a 5. Okay? So just think about when you guys play sports, right? So when they substitute out players, they have to take away the players and then substitute and put in new players. They can't put in new players and then keep the old players in. They got to substitute them out. So I'm taking out the x and I'm substituting in the 5. Okay? So then 7 times 5 is 12. And then we have plus 3. And this equals 15. Right? So that was our end result. We plugged in a 5 and we got an end result. Okay, so that's kind of the big idea for today's lesson. I'm going to give you guys some steps for using substitution, and then we'll go into actually using substitution. Okay, I am going to go very slow during the first problem just because it's so brand new, and I will do the same thing in problem 2. Now let's just talk about what substitution is. So in Unit 5, we talk about systems of equations. Now remember, a system is 2 or more equations. So for example, in the previous days, I'd give you a system. I give you a system and it looks like this. It's 2 equations. And then I ask you to solve it by graphing it. So what do? Well, you get y by itself and then you graph it. You tell me the slope, the y-intercept, you plot it down on your graph, right? So you're solving it by graphing it. Once you've graphed it, are you finished? No, right? Because you have to tell me what the solution is. If I ask you to solve something, you have to give me the answer or the solution. So once you've graphed the system, then you tell me the solution. Well, what's the solution? The solution is where the 2 lines intersect each other, right? This is my solution. So you've solved the system by graphing. Okay? Now, there's 3 types of solutions. You can have one solution where they cross one time. You can have no solution when they don't even intersect. They're parallel lines, right? Or you can have an infinite amount of solutions, infinitely many solutions, or IMS. This means that when you graph it, the lines are right on top of each other. Okay. So substitution is basically another way to solve. So we're not graphing today. You're going to solve the system, but not by graphing. Okay, so steps for substitution. The first step is you're going to look at your equations. You're going to have 2. And you're going to look for the one that has a variable already by itself. Okay? You're looking for a variable that's already by itself. And right now, you don't really know what that means yet. And again, it's just going to take a lot of practice. That first problem is going to be super uncomfortable until you get used to it. All right, number 2. Once you've gotten that figured out, you're going to substitute the expression in parentheses. So remember earlier when we plugged in that 3, right? Yeah, we plugged in the 5, we put it in parentheses. So when you substitute, you're going to put it in parentheses. Okay? You're going to plug it into the other equation. Okay. Once you do this, at this point, only one type of variable should be present. So once you've substituted something in, you either only have x's or you only have y's. You can't have one of each. Like you should only have one of every type, or one of a type. Step 3, once you have a solution for that, you're going to plug it into the other equation. Doesn't matter which equation that you plug it into, you just have to plug it into one. Again, this seems super confusing because we haven't done it yet, but once we get into the examples, it'll make more sense. Once you do this, you're going to solve for the other variable. And when you're finished, how do you write your answer? Whoops. Well, when we graph, oh my goodness. Well, when we graph, right, how do we write our answer? Well, we write it as a point, right? We write it as a point x comma y. So you're going to write your answer as an ordered pair, x comma y. Okay, so these are the steps. Now you're going to get so used to substitution that you don't need to look at these steps, but these are here for you to reference. Okay, so now we're going to start with number 1. The first step in our steps is to look at your equations and to figure out which one of these already has a variable by itself, okay? Now, there's 2 equations here. We have one on the left and one on the right. Now, the one that already has a variable by itself is this one over here. Notice how this already has x by itself, x equals, right? X is already by itself, so that's the one I want to look at. Well, what does x equals? X equals 10 minus 3y, okay? Now, in that first example I showed you, like x equals 5, right? If x equals 5, then what did you do with that 5? Well, you plugged it into the other equation. You're going to do the same thing here, but instead it's not just a number, it's an entire expression. So x equals 10 minus 3y. So you're going to plug this into the other equation in for x. Why do we not plug it in for y? Well, because it says x equals that, so we plug it in for x. Now, when I plug something in, I have to use parentheses. So I'm going to take out that x, and I'm going to substitute in 10 minus 3y. Okay, so what's the only thing I did? I'm replacing this guy. So I have plus y equals negative 10. So what's the only thing I've done here? I've just substituted in my x value and I get 10 minus 3y. Again, this first problem might be super uncomfortable and confusing, but you gotta practice. You're not gonna get it the first time every time. Okay, now once you're at this step right here, how many types of variables do you see? You only see one, right? I see y's only. I shouldn't see x and y. If I see x and y in this step, I've done something wrong, okay? Now, once you get to the step, now it's easy. Now you just do regular algebra math. You're going to simplify this, and they're going to get rid of those parentheses, so we're going to distribute. We're going to do 2 times 10, which is 20, and 2 times negative 3y, which is negative 6y. And then we have plus y equals negative 10. Okay. The next step here is you want to combine like terms. You are always going to have like terms that you can combine. So here I notice that I have negative 6y and positive 1y. Well, what's negative 6 plus 1? Negative 5y. Okay, so we combine those like terms. So all we did was combine. And we're trying to get y by itself. So the next step here is to do what? Subtract 20 on both sides. We have negative 5y equals, well, negative 10 minus negative 20 is negative 30. When I get y by itself, we're going to divide by negative 5 on both sides. And I get y equals, negative 30 divided by negative 5 is positive 6. Now, is this the answer to my problem? Well, remember, when we're solving by graphing, right, when we solve a system by graphing, we have a point. We have a solution point. Right now, all I have is y, right? It's supposed to be x comma y. All I have is the y. I don't have the x. So what does that mean then? It means I have to find the x. So we're going to substitute one more time. So normally when I'm done with my answer, I box it. But here I'm just going to circle because we're just at a checkpoint. Okay, so at this point, right, let's go back to our steps. At this point, you have one type of variable. We did that. Once you have a solution, so we have y equals 6, we're going to plug it into another original equation. So you have 2 choices of equations here. You can pick this one or you can pick this one. It does not matter which equation you choose, okay? So you choose whatever one you want. It doesn't matter which one, they give you the same answer. I'm going to go ahead and pick this one. X equals 10 minus 3y. Okay, well, what do I know? I know y equals 6. So I can plug this in for this y here. I'm going to be drawing a lot of arrows. I'm so sorry. There's going to be a lot of arrows because it helps you visually see what's going on. So I'm going to plug the y, or plug the 6 into the y over there. So I have everything is exactly the same, but now I have negative 3, and I'm going to plug in that 6, right? And that 6 is going to go in parentheses. So I'm substituting the y. I'm taking y out, and I'm putting 6 in because y equals 6. So then I have x equals, well, I have 10. Negative 3 times 6 is negative 18. And let's simplify that. X equals negative 8. 10 minus 18 is negative 8. Okay, well, now I have the x value and I have the y value. So what does that mean? Well, that means my solution is the point negative 8 comma positive 6, x comma y. That's my solution. So what does that mean? Okay, well, let me graph these in Desmos. Oops. We have 2x plus y equals negative 10. Okay, and then we have x equals 10 minus 3y. Okay, so these are the two equations that I gave you guys. So notice if you were to graph this on a graph, you would get these two lines. Well, the solution is where they cross, right? So if I tap on that point, what does it say? Negative 8, 6. Is that the same thing we got? It is. Now you're like, whoa, this takes way too long. Why can't I just graph? Well, if you have to learn substitution, you can't really be graphing, right? You have to learn a different skill. So if they don't give you a graph, graphing is not an option for you at that point. Okay, so what does that mean then? That means if I were to graph this equation and graph this equation, they cross at the point negative 8, 6. Okay, so how could I check this? Now, I'm not going to make you check on every problem, but I am going to show you that you can check. So let's go ahead and pick that first equation. 2x plus y equals negative 10. We're just going to check here. Okay, well, I know the solution is negative 8, 6. So what can I plug in for the x? I can plug in negative 8. I can also plug in for y, I can plug in a 6, right? And notice how every time I plug in, I use parentheses. So let's check this. 2 times negative 8 is negative 16, and we have plus 6 equals negative 10. And then we have negative 6 plus 6, well, that's negative 10. Does negative 10 equal negative 10? Yes, it does. So that's indeed my answer. That's my solution. Okay, so that first one was always going to be rough because it's the first one you do. But you'll notice as we go on, we're doing the same thing every time. Okay, number 2. First step is you're going to look at your equations. Figure out which one of these has a variable already by itself. In this case, the one that's already by itself is over here on the left. X equals 1 minus 2y. Okay, so I'm going to substitute 1 minus 2y in for something, okay? X equals 1 minus 2y. So I'm going to plug this in for x. I don't want to plug it in for y because it says x equals. When I plug in, I use parentheses. Okay, so I have 2y minus 7, right? So the 7 doesn't go away, only the x. I take out the x and I substitute in 1 minus 2y equals negative 7. Okay, at this point, you should only see one variable or one type of variable. Right here, I only see y's. I don't see any other x's. They've gone away. Okay, so next step here is we're going to distribute. So I have 2y, negative 7 times positive 1 is negative 7. Negative 7 times negative 2y is positive 14y. And then we have equals negative 7. Okay. Next step, you always have like terms, so you want to check for them. We have positive 2y plus 14y. Well, 2 plus 14 is 16, so I have 16y minus 7 equals negative 7. Okay? Well, I still want to get y by itself, so I'm going to add 7 to both sides. So I have 16y equals negative 7 plus 7 is 0. Okay? Now, is y by itself yet? No. Still need to get y by itself, so we're going to divide both sides by 16. 0 divided by 16 is 0. Is y equals 0 my answer? No, it's part of my answer. Remember in the last problem, it's only half, right? You're getting x and y. Right now, all we have is the y. We need to find the x. So y equals 0 is part of my answer, but it's not the end answer. So then I pick an equation. It doesn't matter which equation you pick. Let's go ahead and pick the first one. X equals, excuse me, x equals 1 minus 2y. Well, what do? Well, I know that y equals 0, so I'm going to plug this in for the y because y equals 0. So I have x equals 1 minus 2. I plug in a 0 for the y with parentheses, right? Okay, now I continue. X equals 1. Well, what's negative 2 times 0? 0, right? So minus 0. Well, then what does x really equal? 1. So x equals 1 is the other half of my answer. So what is my solution? Remember, it's x comma y. It'd be 1 comma 0. That's our solution. Okay, so what does that mean? That means if I were to graph this equation and graph this equation, they would cross at the point 1, 0. That's what that means, okay? All right, moving on to number 3. 2y equals 2 minus 2x and y equals 16 minus x. Okay, first step, same step as always. You look for the equation that already has a variable by itself. This one is going to be y. Y is already by itself, so we're going to go ahead and circle 16 minus x. Where am I going to plug that in? I'm going to plug it into the other equation. What variable do I plug it in for? Y, because it says y equals. So I plug this in for the y. I would not plug it in for x over there. So when I plug in, remember we use parentheses. So 2, and then we plug it in the y. So parentheses 16 minus x. The y goes away, and we plug in the expression. Equals 2 minus 2x. Okay? What's the next step here? Distribute. 2 times 18 is, or 2 times 16 is 32. 2 times negative x is negative 2x. And then we have equals 2 minus 2x. Okay, well at this point, what do? Well, we only want x on one side, so let's go ahead and get x by itself. Which side do you want it on? It doesn't really matter. I'm going to go ahead and I'm going to move the x to the right. So I want to move this guy over to this side. Well, how could I move it? I would have to do the opposite and add 2x on both sides. So then I would have 32, and then negative 2x plus 2x will cancel because it's 0. Negative 2 plus 2 is 0. And then I have equals 2, right? Now, what happens over here? Negative 2 plus 2 is 0. So that also cancels. So all I have left is 32 equals 2. Well, does that even make sense? No, it doesn't make any sense. So what does that mean? It means no solution because it doesn't make sense. Remember, if it makes no sense, it's no solution. If it makes no sense, it's no solution. So let's say, for example, you do all your math and then you get to 1 equals 5. What does 1 equals 5? Or does 1 equal 5? No. Does 2 equal 7? No. If you get something that makes no sense, it means no solution. So what does that mean if I were to graph these two equations? Well, let's see. We have 2y equals 2 minus 2x. And then we have y equals 16 minus x. Okay? Look at your lines. They're parallel. Are they ever going to cross each other? No. If they never cross, then it means there's no solution. So again, it's the same thing. We get the same answer when we graph, but this is just another way to do it by algebra, okay? So number 3, we have no solution because the answer makes no sense. Makes no sense. So it's no solution. Okay, number 4. Y equals x minus 7 and 4x minus 3y equals 15. Which one of these has a variable already by itself? This one over here already has a variable by itself. Y equals x minus 7. So I'm going to plug in x minus 7 into the other equation, but which variable do I plug it in for? I plug it in for y because it says y equals. So, oops. Oh, it's erasing things. I don't want it to erase these things. Okay, so I'm going to plug this into the other equation in for y. So then I have 4x minus 3. Remember, I'm taking out the y and I'm substituting in x minus 7, okay, because y equals that. Again, this just takes a lot of practice. So if you're getting more used to it, that's great, but if you're not, you're going to need more practice. All right, so at this step, we're going to distribute. So we have 4x. Negative 3 times x is negative 3x. Negative 3 times negative 7 is positive 21 equals 15. Now, at this step, you check for like terms, right? 4x and negative 3x are like terms. 4x minus 3x is just 1x. I could just write x, right? But I could write 1x too. But I'm going to write x. So plus 21 equals 15. We need to get x by itself, so we're going to subtract 21 on both sides. So x equals 15 minus 21 is negative 6. Is this my answer? No, but it's part of my answer, right? So I'm going to go ahead and I'm going to pick an equation to plug it into. And just for the sake of it, I'm going to plug it into this one. 4x minus 3y equals 15. Okay, so what would I do with the x equals negative 6? Well, now I'm going to plug it in for the x, okay? I'm going to plug it in for my x variable. So then I have 4 times negative 6 minus 3y equals 15. I'm plugging it in for the x variable because I know x equals negative 6. So 4 times negative 6 is negative 24. We have minus 3y equals 15. We get y by itself, so I'm going to add 24 to both sides. Negative 3y equals, well, 15 plus 24 is 39. Divide both sides by negative 3, and we get x equals negative 13. So what does that mean? Oh, y equals, not x. Be super careful about that, because I just messed up. So y is by itself, y equals negative 13. So that's the other half of my solution. So my solution is what? It's the point negative 6, negative 13. So if I were to graph this equation and graph this equation, what happens? They would cross at the point negative 6, negative 13. Now, did I have to plug it into this equation? No, right? If you notice and if you look, that took a long time to get us to get y. Couldn't we have just plugged it in to this equation over here? Well, let's find out. Y equals, let's plug in negative 6. We get y equals negative 13. Didn't we get the same answer? Yeah, but it took way less time, right? So again, you choose what equation you want to plug it into. Usually the one that already has a variable by itself is going to be the easier one to plug it into. All right, moving on. We have 2 problems left. 5, x equals 4 minus 2y, and 4y plus 2x equals 8. Okay, first step, you look for the one that already has a variable by itself. So this one I noticed that x is already by itself, so I'm going to use 4 minus 2y and substitute it in. We're using substitution. We're going to plug this into the other equation in for the variable of x, okay? So then we have 4y, 4y plus 2. We substitute the x out and we put in 4 minus 2y equals 8. The next step here is to distribute. 4y, and then 2 times 4 is positive 8. 2 times negative 2y is negative 4y equals 8. From this step, you look for like terms. Do you have any? 4y and negative 4y. What's 4 minus 4? 0. So what happens? They cancel each other out. They go away. 4 minus 4 is 0. There's nothing left. So what do you have left here? 8 equals 8. Does 8 equal 8? Yes. Did 32 equal 2? No, right? So because it makes no sense, it's no solution. But if 8 does equal 8, then what does that mean? It means infinitely many solutions, or IMS. What does that mean then? It means if I were to graph this equation and graph this equation in Desmos, what would happen? They'd be on top of each other, right? It'd be the exact same line. X equals, I think it's 2y minus 4, I believe. Oh, 4 minus 2y. Close, sort of. 4 minus 2y. And then the second equation was 4y plus 2x equals 8. 4y plus 2x equals 8. Well, what do you notice as I click back and forth? They're the exact same line, which means it crosses infinitely amount of times. So this is infinitely many solutions. Does 5 equal 5? Yes, so that would be infinitely many solutions. But if you got like 5 equals 3, then that'd be no solution. Okay, number 6 is a combination of what we've done all units so far. So it's going to be a combination of setting up the system and then solving the system. But we're going to solve using substitution. Okay, so I'm going to read the problem. There are 18 cars in a parking lot. There are 4 more red cars than green cars. Write and solve the system to find the number of red and green cars. So just talking about this problem, I notice that I'm talking about 2 types of cars here. I'm talking about red cars and green cars. So I'm going to go ahead and make x my variable for being the number of red cars, which means y will be the number of green cars. Okay, so I have my 2 variables. Well, the first sentence says there are 18 cars in the parking lot. So in total, I have 18 cars. Well, what makes up the cars? Red cars and green cars. So my first equation would be x plus y equals 18. Let's see if this makes sense. What does x represent again? The number of red cars. So does the number of red cars plus the number of green cars equal 18? Yes, it does make sense. Now, once I've used the number 18, can I use it again? No, right? I can't use it anymore. Okay, the next sentence says, there are 4 more cars or 4 more red cars than green cars. So we're comparing the 2 types of cars here, the amount of how many we have. So this means that our variables are going to be on opposite sides of an equation with each other because we're comparing them, or we're trying to balance now. There are 4 more red cars than green cars. So which one has more cars? The red cars. There's more red cars. So if I have more red cars, I want to balance it out. Well, which variable is red cars? X. So X is more. We want to balance it out. So what should we do? Well, it says 4 more. So let's add 4 more to the Y. Now, the reason why it's not 4Y is because it doesn't say 4 times, right? It just says 4 more. So you would add 4. Okay, remember, it's like a balancing thing. You're trying to balance the number. So you have more red cars, so you're going to add 4 more to the green. Now that you have your equations, we're going to solve it by using substitution. So I'm going to go ahead and copy my equations over here. Okay, so these are my 2 equations. We're going to solve using substitution. So which one of these already has a variable by itself? This guy. So that one already has a variable by itself, so we're going to get y plus 4, and we're going to substitute it into the other equation in for x, okay? So x equals y plus 4, so I'm going to plug it in for x. So this x goes away, right? We're substituting it in, and we have y plus 4 plus y equals 18. So we're just substituting that x, we're getting rid of the x, and putting y plus 4. Okay, now from this next step, I see parentheses, but what number is in the front here? A positive 1, right? Well, 1 times y is just going to be y, and 1 times 4 is just positive 4, so it doesn't change anything. So plus y equals 18. Next step, look for like terms. Well, I have y plus y. Well, what's 1y plus 1y? 2y plus 4 equals 18. Okay? Next step here, we're trying to get y by itself, so we're going to subtract 4 on both sides. 2y equals 12. Because wait, is that 12? No, it's 14, I'm sorry. 18 minus 4 is 14, I'm sorry. And then we divide both sides by 2, and we get y equals 7. Now, what does that mean? Well, remember, y represents what? The number of green cars. So this would be that there's 7 green cars. okay? That's part of my answer because I want to find the number of red cars too, so I have to find x as well. Well, I know y equals 7, so now I just have to pick one of my equations. It doesn't really matter which one I pick. Let's go ahead and pick, let's pick this second one over here. X equals y plus 4. Well, I know that y equals 7, so let's plug this in for 7. So we have x equals, you plug in a 7 there, so we have 7 plus 4. Well, what's 7 plus 4? 11. So x equals 11 is the second part of my solution. Well, what does that mean? Well, x represents the number of red cars, right? So that means we have 11 red cars. So the reason why we don't write this answer as a point is because we're talking about cars here. So if someone asks you how many cars are in the parking lot, you don't say 11, 7, right? You tell them 11 red cars and 7 green cars. Now, before we finish this problem, does it make sense that we have more red cars than green cars? Yes, because in the problem it says that there are 4 more red cars than green cars, and that's true. All right, so that is it for the notes for the first day of substitution. If you have any questions, please feel free to come in and ask.